What is a castle made of? Bricks. What is a human made of? Cells. What is a cell made of? Molecules. And molecules are made of atoms. So if we understand atoms completely, do we understand everything else? This is the oldest debate at the heart of science. It pits two powerful ideas against each other. Reductionism and emergence. Reductionism says, the whole is nothing but its parts. Emergence says, the whole is more than the sum of its parts. Welcome to Grossdenken, everyone. Today, we are going to explain both ideas, show you how scientists actually use them, and reveal why the debate might be more complicated than you think. Please support this channel by just subscribing. That would mean a great help. Reductionism is the approach of explaining complex phenomena by breaking them down into their smallest, most fundamental components. It is the idea that if you understand the parts, you understand the whole. This approach has been incredibly successful. We understand genetics because we reduced it to DNA and RNA molecules. We understand chemical reactions because we reduced them to atomic interactions. We understand ideal gases because we reduced them to models of non-interacting point particles. Physicists like Newton, Einstein, and Feynman were all reductionists in their own way. The goal was always to find the fundamental laws that govern everything, to find the smallest pieces and the rules they follow. A famous slogan of reductionism is, "Wholes are nothing but their parts." If you know everything about the parts, you should in principle be able to predict everything about the whole. But here is the problem. There are phenomena that seem to defy simple reduction. You can understand a single neuron perfectly, but that does not explain consciousness. You can understand a single water molecule, but that does not explain the properties of a wave crashing on a beach. You can understand individual atoms, but that does not explain the behavior of a living cell. In 1972, the physicist Philip W. Anderson published a landmark article called "More is Different." His argument was simple. When you put enough parts together, new properties emerge that cannot be predicted from the parts alone. A crystal forms not because of the laws of individual atoms, but because of the collective arrangement of billions of them. The behavior of the whole is not contained in the parts. It emerges from the interactions between them. Emergence is the idea that complex systems can exhibit properties that are not reducible to their constituent components. Think of an ant colony. Individual ants follow simple rules, but collectively, the colony builds complex structures, finds food, and defends itself. The colony's behavior emerges from the interactions of the ants. It is not pre-programmed in any single ant. Consciousness is another classic example. No single neuron is conscious, but billions of neurons interacting produce consciousness. That is emergence. As Anderson put it, a water molecule is not wet. Wetness is a property of the collective behavior of billions of water molecules. It emerges from the interactions between molecules. It cannot be reduced to the properties of a single H2O molecule. Here is the honest truth that scientists have come to realize. Reductionism and emergence are not enemies. They are complementary tools. Reductionism is how we find the fundamental building blocks. Emergence is how we understand what those blocks build when they interact. Even in fundamental physics, emergence appears. Researchers have proven that in certain quantum systems, macroscopic properties like magnetization are impossible to derive from just knowing the microscopic interactions. They literally cannot be reduced. This has profound implications. It means that even if we discover a theory of everything, the ultimate laws governing all particles and forces, that theory alone may not explain everything. We would still need new concepts and principles to understand the emergent behavior of complex systems. The physicist Piers Coleman has described this relationship using the ideas of the philosopher Francis Bacon. Bacon argued that science does not start from grand principles. It starts from observation and experiment. We move gradually upward from specific observations to general principles. In this view, reductionism and emergence are an awkward alliance. Reductionism tells us to look for the parts. Emergence tells us to look for the patterns that arise when parts interact. Both are necessary for a complete understanding of nature. So what is reductionism versus emergence? Reductionism is the belief that the whole is nothing but its parts. Emergence is the observation that the whole can have properties the parts do not. The most powerful science uses both. It reduces systems to their components to understand the machinery. And it studies the collective behavior to understand the patterns that emerge. That is the beauty of science. It does not choose sides. It uses whatever tool works. Thanks for watching and hit subscribe for more deep dives into the ideas that shape how we understand reality.